Hello, and welcome to my channel, Reading Little Blue Books Out Loud. This is a little blue book. It just happens to be Little Blue Book number 409, and it is entitled Great Men of Science, written by Hereward Carrington, Ph.D., and it is copyrighted 1924. So this is Great Men of Science according to 1924. This is part 2. And we left off at the top of page 16, and the new chapter is Astronomers. The ancient Egyptians and Chaldeans were, as we know, astronomers of no mean order. The pyramids and what records have come down to us prove that, in Alexandria, Arcticus first attempted to estimate the relative distance of the sun and the moon. He even computed the size of the earth, and his calculations were not far out, viz. 30,000 instead of 25,000 miles in circumference. It is to be noted that this was made on the implicit faith that the earth is round. As Snyder says, it is indeed one of the strangest lapses of history that perfectly clear and just notions respecting the form of the earth and its motion round the sun should have grown up among men, have been passed from one century to another, and then disappeared from Christendom for 1,000 years. Pythagoras taught the motion of the earth, and Nicetas of Syracuse taught its motion about its axis as well. But Ptolemy, 130 AD, however, then propounded his views, which dominated the minds of men for more than 1,500 years, until Copernicus, Galileo, and Newton came upon the scene. Copernicus, 1473 to 1543 AD, was the first man who dared challenge the Ptolemaic system. He was not a great genius, but he possessed infinite patience and devoted years to the observing of the motion of the heavenly bodies. He demonstrated with minute detail that the heliocentric theory would satisfy all observations as well as the geocentric, and that the idea that the earth revolved around the sun was simpler than the contrary. Tycho Brahe, 1546 to 1601, was a painstaking observer. He made a series of excellent observations. He found the length of the year with an error of less than 1 second of time. Galileo, 1564 to 1642, is the next great name we encounter in the history of astronomy. He published a vigorous defense of the Copernican system, which caused his persecution by the Church, as we know. Kepler, 1571 to 1630, was a pupil of Tycho Brahe, and for many years studied the motion of the planet Mars. He made a number of successive discoveries and advanced at various times his laws of planetary motion, the three most important of which are: 1. The orbit of every planet is an eclipse with the sun at one of its foci. 2. Every planet moves so that the radius from the sun to it sweeps over equal areas in equal intervals of time, whatever their length. 3. The squares of the periods of any two planets are to each other as the cubes of their respective means distances from the sun. Sir Isaac Newton, 1643 to 1727, then came upon the scene with his law of gravitation, which he applied to Kepler's laws, finding that it agreed perfectly. Newton's influence upon astronomy has been immense, and has colored and influenced all subsequent research and scientific theories. Halley, 1656 to 1742, a brilliant astronomer, was the discoverer of the comet which bears his name. He had noted that the comet observed by him in 1682 had appeared at intervals of 75 years, and he accordingly predicted that its next appearance would be in the year 1759. It was observed when predicted. This was the first time that verification of such a prediction had been made. Sir William Herschel was born in 1738 and moved to England from Hanover while still a young man. In those days, telescopes were very rare, very expensive, and not very efficient. He was driven to the stupendous task of constructing one for himself. Purchasing some amateur's paraphernalia for grinding and polishing lenses, and trolling with his sister in those seasons of the year when the fashionable visitors had quitted Bath, in 10 years he had the satisfaction of surveying the entire heavens with a Newtonian telescope of 6 feet focal length, made by his own hands. Herschel's chief contribution to astronomy was his discovery of the planet Uranus. 2 of the 4 satellites of Uranus were discovered by William Herschel in 1787. About 1840, Adams of Cambridge, England, and Leverrier of Paris independently took up the problem of finding the position of the unknown body causing the perturbations in the motion of Uranus. Leverrier sent his results, which agreed nearly with those of Adams, to the German astronomer Galilei, who found the new planet the first evening he looked for it, September 23, 1846. This has always been regarded as one of the greatest achievements in mathematical astronomy. The Italian astronomer Giuseppe Pirelli was the first to discover the so-called canals on Mars, and startled the world by his announcement. His findings were confirmed and greatly extended by Percival Lowell, who devoted a large part of his life to their investigation. He published a number of books and scientific papers upon the subject. The 2 most known probably being Mars and its Canals, and Mars and the Abode of Life, in which he attempted to prove that Mars was quite capable of supporting animal existence. His findings have been questioned by many other observers who have been unable to see the canals with the same degree of clearness as they were perceived by Lowell. The matter is still in dispute. We must now mention very briefly the cosmic theory proposed by Laplace. In 1796, he published a treatise upon astronomy in which he advanced his famous ring hypothesis to account for the formation of the solar system. This was the Laplacian theory. It contended that the Earth and other planets are merely fragments of the original Sun, which fragments had been cast off in past ages and sent spinning into space. There they were held by the forces of gravitation and had gradually cooled. This hypothesis was generally accepted in principle for more than a century, despite the obvious difficulties in the way of its acceptance. It was not until the beginning of the present century that another and more reasonable hypothesis was found to take its place. This was the planetesimal hypothesis, advanced by Professors Chamberlain and Moulton, which had since been practically adopted. It is based upon the idea that our Earth and all similar planets were formed by gradual accretion of smaller bodies, originally cooled, which became heated by impact when drawn into the main body. Observations upon spiral nebulae had tended to confirm this theory, and subsequent investigations have also done so. These 2 astronomers may be said to have advanced a theory, therefore, replacing the older Laplacian hypothesis and capable of explaining practically all the known astronomical phenomena in a satisfactory and rational manner. Savant Argenis, director of the Nobel Institute, has advanced various ingenious views which have greatly influenced modern astronomy. Among these may be mentioned the importance of light pressure, because of which the comet's tail always turns away from the sun. Also the possible transmission of dust particles, bearing microscopic life across space, etc. Several of his books have been translated into English, such as Worlds in the Making, The Destiny of the Stars, etc. Among recent or contemporary astronomers, we may notice Simon Newcomb, Pickering Maunder, Wilson, Lameron, Bernard Campbell, Captain Locklear, and TJJC, as in SEEC. Next chapter. Take a swig of coffee. Next chapter is chemists. In my book on chemistry for beginners, in the present series, I have briefly outlined the history of this science, the early Greek philosophers and their views, the stories of the alchemists, and also summarized the theories held during the so-called atrochemical period and the phagogistic period. It will be unnecessary, therefore, to refer again to these ideas and to the men who held them, with a few exceptions: Democritus, Lucretius, etc., who held a form of the atomic theory; Roger Bacon, who was a true experimentalist as well as an alchemist, etc. The early history of chemistry yields but few great names. Modern scientific chemistry begins with Roger Boyle, 1627 to 1691. He published a number of valuable pages, full of speculations and experimental results. He was the first exponent of the truly experimental method along scientific lines. His Skeptical Chemist is his best-known work, though he published several other books as well as numerous papers. A contemporary of Boyle, who made important observations on combustion, was Robert Hooke, 1635 to 1702. Lemery Knuckle and Becker were important men in this field at the time. Stahl, Hoffman, and Boerhaave were all noted chemists of the 17th century. Merkur and Black were also famous chemists. Cavendish, 1731 to 1810, and Joseph Priestley, 1733 to 1804, were, however, the two great names of this period, and together with Shelley, the discoverer of nitrogen, and Stahl, they may be considered the great names before Lavoisier. Lavoisier, 1743 to 94, the discoverer of oxygen, marks the end of the old philologist period and the beginnings of modern chemistry. The amount of experimental work he accomplished was extraordinary and was of the highest value. He was beheaded during the French Revolution. Other great chemists of his day were Gaudin de Morvois, Berthold, Poelcry, Kerwin, Richter, Proust, etc. Scott loves to use the etc. We now come to John Dalton, 1766 to 1844, and the atomic theory, which marked an epoch in the history of chemistry. Gay Lussac and Humphrey Davy, the inventor of the safety lamp for use in mines, were also great chemists of this day. Both men carried on a vast amount of valuable experimental work. Gay Lussac first formulated the law of volumes, and the connection between this and Dalton's atomic law was worked out by Avogadro, 1776 to 1856, and Italian William Prout, 1785 to 1850. Advanced at about this time his famous hypothesis, in which he advocated the common origin or genesis of the elements. We now come to Berzelius, 1779 to 1848, one of the great names in the history of chemistry. He introduced many improvements in analytical chemistry and devised the present system of chemical formulae. Mitscherlich, 1794 to 1863, and Jean Dumas, 1800 to 1884, are also great names of this period. Liebig, 1803 to 1873, was one of the first great organic chemists. He made many valuable discoveries concerning the chemistry of the human body. Wöhler succeeded in synthesizing urea, an organic compound. Bunsen, 1811 to 1899, enriched nearly every branch of chemistry by his valuable researches. Laurent, 1807 to 1853, was a noted organic chemist of this period. Franklin and Van 't Hoff are also noted names. Dmitri Mendelhoff, 1834 to 1907, was the formulator of the famous periodic law, one of the greatest generalizations of modern science. It has been preceded, however, to some extent by the work of Newlands and Mayer. I have explained the nature of this great law in my Chemistry for Beginners in the present series. Among the great names which should be mentioned about this period or earlier are Count Rumford, Faraday, Pasteur, Kirchhoff, Roscoe, Huggins, Lockyer, Wollaston, Tennant, Thorpe, and Berthelot. These men all made original discoveries and made much to the science of chemistry. Sir William Crookes, the inventor of the Crookes tube, which led to the discovery of X-rays, and discoverer of the element thallium. He discovered thallium. Was one of the great names of the last century. He wrote on theoretical and applied chemistry, as well as being a resourceful experimenter. Crookes, while primarily a chemist, was also a physicist, and his inventions marked the beginning of that approach between chemistry and physics, which is now so apparent. Lord Rayleigh and Sir William Ramsay jointly discovered the element argon in the atmosphere. Towards the close of the last century. Helium was discovered by Ramsay in 1895. This investigator's later researches seemed to demonstrate the transmutation of certain elements and were instrumental in ushering in the new alchemy. Henry Becquerel had found in 1896 that certain compounds of uranium spontaneously emitted some radiation, which, among other properties, had that of making air a conductor of electricity. Following up this line of investigation, M. and M.E. Curie discovered the wonder element radium, the salts of which they separated in 1898. This led to opening up of the whole field of radioactivity, and a number of investigators were soon at work. Chief among these we may mention Rutherford, Soddy, de Broglie, Geisel, Macquer, Lewis, and others. This has led in turn to new theories as to the structure of the atom. The ingenious theories have lately been advanced by Bohr, Milken, Langmuir, etc., as to its inner structure. Ostwald in Germany is one of the greatest living chemists and the propounder of the doctrine of energetics. Zsigmondy of Grottingen is noted for his researches with the ultramicroscope. Baskerville and Duncan were two noted American chemists. So many eminent men are now at work upon these problems, however, that it would be impossible even to enumerate their names. The fields of physics and chemistry are now so close that it is no easy matter to say where the one begins and the other ends. Chemists are now also physicists, and vice versa. Since the discovery of radioactivity, explorations as to the nature of the atom and the ultimate constitution of matter have greatly complicated the problem. The chemist no longer deals solely with matter, and the physicist with energy. The discovery of the electrical nature of matter has changed all of that. This will become clearer to us after we resume of the history of physics. And I think we'll end there with part 2.